Okay, let's get into it and do the full deal. So we're starting with a function. I'm going to start you with a quadratic because the algebra is a little nicer, but you already know the hard algebra as well. So what I hope you see here is that at least for this first part, we are barely adding anything new from what we were thinking in 1.0 and 1.1. If I would like to find, oh my goodness, I think I see a typo. I think what I was hoping for was to find f prime of -3. If I would like to find that, I'm going to go straight to the definition of the derivative, which tells me to find the limit as h approaches 0 of f of -3 plus h minus f of -3 all over h. My function is f of x equals 2x squared minus x. So this will turn into limit as h approaches 0. Keep that limit until you evaluate it, of 2 times -3 plus h squared minus -3 plus h. And then I need to subtract off that original function evaluated at -3. So we'll say minus 2 times 9, basically, so 18, minus -3, so there's going to be a plus 3 in there, and that's all divided by h. So let's start simplifying. Keep that limit. We haven't evaluated it yet. We have 2 times -3 plus h times -3 plus h. That will give me 9 minus 6h plus h squared. I need to distribute a negative in really carefully. That will give me plus 3 minus h. And then I have at the end a minus 21 all over h. This becomes the limit as h approaches 0 of 18, again distributing in here, minus 12h plus 2h squared. And then I can do just a little bit of combine while I'm in here. I'm going to give that a -h minus 18. And that's starting to look promising. So the 18s will drop out. It looks like that's the only thing that drops out, but I feel okay about that. I already got rid of some things earlier. What I'm liking is that I can factor in h out of what's left over. So I will have h times -12 plus 2h minus 1. Don't forget the minus 1. That's kind of a common error. The h cancels out, and now I can finally evaluate the limit. So as h goes to 0, this middle term is going to fall out, and the -12 minus 1 will be left over. Oh, I guess I could have combined, I'm just now noticing. But this will get me there, equals -13. Okay, so this should feel very familiar. I am plugging in a specific x value here, so it actually might feel a little bit easier, although at first that might throw you a tiny bit. In 1.4, we'll just keep the x in there instead of plugging in the -3, and that should feel even more like the exact same algebra we were practicing earlier. So hopefully a lot of this doesn't feel very hard after all the practice we've been doing. Part B is a little bit of a new one, but it's really just an algebra question. Part B wants us to now find the actual equation for the tangent line at x equals -3. The important thing here is that you remember that f prime of -3, what we just found, is the slope of your tangent line. So we've already got that key piece of information. We know that the slope is -13. We also already know what our x is. To find the equation for a line, we just need to know what our y is. And this part, sometimes people will space on until they've practiced a little bit. We have a formula right here that we want to be tangent to. if we're going to be tangent to that formula, we better make sure that our line goes through the exact same point as that function. So to find the y for our line, we find the y from our function. We plug that -3 back in, and we've actually already done that calculation along the way. That was this 18 plus 3, which ended up being a 21. So the point that we want our line to go through is -321. So I'm planning on using my point slope form. Feel free to use your slope intercept form if you like it better. I used to always just use slope intercept form, but I've kind of gotten to like the point slope form, just setting it all up for me. So I'll have a y minus 21, y minus your specific y value, equals our slope times x minus x1, or x minus our specific x value. Since our x value is negative, that becomes a +3. And then we just have a very small amount of rearranging to do. I'll distribute that -13 through, and I'm also in that same step adding the 21 to move it over from the left-hand side. So all put together, I get that y equals -13x minus 18. Okay, so I do have one last task for us now that we've done all the hard parts. Let's check this graphically. I do think you should have a pretty good idea of what 2x squared minus x look like without using technology, but let's use Desmos to make sure that we've got this right. All right, so we had y equals 2x squared minus x. So that's what our graph looks like. We want to be able to see -321. I'm going to adjust just my x-axis for a minute. We really only need -4 to, I don't know, 2-ish. Okay, so -3, yep, I can see it now. There's the point that I'm interested in, right around there. And then the tangent line that I found was y equals -13x minus 18. And that looks pretty fantastic, actually. It finds that point for us because that's where the two intersect, which they should. It does look like we have a really nice matchup. We can zoom in and make sure our local linearity looks good if we want to. And I think it's looking fantastic. So very nice fit. So again, you should be able to sketch those by hand, at least the fairly easy quadratics, but Desmos is a great check.